Good morning and good afternoon, everyone, and thank you for joining us for the webinar, The Truth About Real Big Data. My name is Michelle Helling, the Director of Marketing at Rocana, and I will be your host today. We've got a great session for you today, so without further ado, let me go ahead and introduce you to Rocana's own COO, Don Brown. Don, the floor is yours.
Thanks, Michelle, and thanks everybody for joining today and taking some time out here today to kind of wrap your heads around what we consider to be the real definition of big data systems, particularly as it regards IT operations and security. So as Michelle mentioned, my name is Don Brown. I'm COO of Rocana. I primarily come from a software engineering background. I actually started working at IBM when I was 16 years old doing encryption research, did that for a number of years. Eventually moved into more of a network management role at Earthlink and actually ran the NOC there for a number of years, and then moved into much more of an infrastructure and security facing role. So early in my career, I spent a lot of time working with tools that look a lot like the monitoring tools you see today. Splunk, ArcSight, things like that. But actually, even a little bit more legacy, the BMC Patrol, the Netcool, the Micromuses of the world. And so I've kind of lived through a few of the inflection points in our industry. After CompuCredit, I actually moved into a role, a solution architect role at a company called Cloudera. Most of you are probably familiar with it. Looks like there are a few people from Cloudera on the line. What my role there was really kind of building, given my background, building high-speed ingestion pipelines under a variety of different use case code names. The predominant one was known as Splunk Offload, also known as Splunk Killer, Splunk Lite, centralized logging infrastructure, you name it, we kind of heard it. But the end goal there was really to capture data from an entire organization, or at least an entire business unit, and move it into a repository in which it could be analyzed much more effectively than historically had been possible with either existing technology, relational databases, or even proprietary tools that have been built up over time. So we did that dozens of times, built these systems over and over and over again, all the way up to capturing a petabyte of data a day for one of these systems. We don't really even think about having to scale working on Hadoop-based systems until you're talking about at least tens of terabytes, preferably hundreds of terabytes. And so what we learned through that cycle, and my co-founders at Rocana, Eric Sammer and Omer Tryman, were also part of that services team. What we learned through that cycle was, while we could build these things and we would be able to be successful and the customer would be able to capture all of this data, when we would leave, because it was delivered as services, what they would be left with was their own work product. And so they were left to their own devices for the monitoring, the maintenance, the extending, and more importantly, the analytics, which is actually the really interesting part. Who cares if you can capture all of the data? You can't actually do anything with it. And so that's kind of the genesis of how why we started Rocana. And I'm going to kind of jump into the problem space that we see particular to IT operations. And then jump back into kind of the analytics in a little bit. So really, we're at an inflection point, I think, in the history of IT operations and monitoring analytics systems. I think back in the 80s, we saw the kind of rise of mainframes, minis, and their use in graphical applications. And you saw that first crop of what I'll call enterprise monitoring applications grow out of that. The BMCs of the world were created back in the mid-80s. In the 90s, we then saw a change in the way that applications were deployed and delivered to users. And we saw that kind of move from the mainframe much more to the traditional client server of the early 90s. And so we saw a move much more towards a monitoring tool that would reflect that, reflect the ability to capture from disparate sources across the stack. Obviously, in the late 90s, we saw the move to the web, which drastically affected the needs for monitoring capture, and it in particular affected the scope of data that was involved. So as I'm sure some of you can remember, at least back in the early 90s, we're talking about, I remember my first machine, the first machine I personally bought had 540 meg of hard drive space, and that was actually pretty big at the time. We're talking about capturing terabytes and petabytes of data now. And so as we move into the web era and you start to see the emergence of Facebook, kind of the modern web companies, we're at now a new inflection point. And additionally, we have this kind of overly complicating factor, or compounding complicating factor anyway, in terms of we've moved past one server being one server. With the advent of virtualization, containerization, no longer do 10,000 servers, 100,000 servers equate to the number of entities that you have to manage and monitor. We're now talking about millions of entities under management, particularly when you're talking about the Fortune 100, 500, 1,000, across many data centers. And really a new approach is needed in terms of trying to understand and wrap your head around being able to derive analytics and intelligence out of those systems. So I think it's not news to anyone that we're kind of seeing a massive influx of data growth. You see these reports about once a week. I see them almost every day, given that I follow the space very, very closely. And in particular, because of the trend that I just mentioned, we're seeing an even more drastic growth in the rise of machine data. You see the world of Internet of Things, which tends to be kind of a whole bunch of different use cases amalgamated in this umbrella term. The rise of kind of decoupled microservice type applications, and in particular, the breakout of mobile devices and services has led to a proliferation of things new to monitor, which require new ways of monitoring. And it actually has really kind of broken down the paradigm that we've been successful with in the past in terms of being able to just simply search for data. Because it's no longer possible for any one person to keep a representation of all of those millions of entities I just mentioned in their head. Everything eventually spills to disk. But more importantly, outside of the entities themselves, what's even more important is keeping a representation of all of the relationships between those things is simply an intractable problem at the scales that we're talking about. So as we started to kind of create the Rocana, we took a step back and we looked at the experience that I mentioned before around building these large-scale ingestion pipelines for some of the largest organizations in the world. And we really kind of dove in and tried to understand what are the problems that you actually want to solve. Separate the conversation from the legacy tools, break out of the mindset that you've had historically in terms of, I collect my storage data with these tools, I collect my network data with these tools, I collect my application data with these tools, I collect my metric data with these tools, and really kind of step back and say, what are you actually trying to accomplish with all these monitoring tools? Because quite frankly, at the end of the day, no one cares whether how many machines you have under management, what your mean time to resolution is. What people actually care about is service quality and maintaining that service quality across the breadth of your applications. The holy grail in monitoring is not to get to that largest number of mean time to resolution, and not to get to the greatest or smallest ratio of servers under management per operator. The holy grail is to actually identify as quickly as possible, and ideally before the application users even know that there's a problem, that there is a problem, be able to identify it and remediate it, and then in particular be able to prevent that problem from happening again. So if you look back at the silo problem that I just mentioned across the kind of the storage, application network, et cetera, that's the first problem that we really wanted to break. And that requires, quite frankly, a repository like Hadoop, someplace where you have the ability to store unstructured data, apply probably some loose structure, a loose schema to it so that you actually can do analytics, but effectively this massive bit bucket that I don't particularly care how much data goes into it. It's not a SAN. I'm not paying crazy numbers of dollars per byte, because a lot of this data has very, very little value at the time that you actually create it and put it into the system. It's very, very difficult a priori to know what the value of data is, and we'll dive into that in a little bit, and some particular examples around that. Second, what we heard and kind of saw as we watched users trying to fumble through these systems, and again, I was a user of these systems myself for a number of years, is search is a really, really broken metaphor. Search insists a priori that you know what you're looking for. And if you're that guy in the NOC, you're the guy in the war room at 3 o'clock in the morning trying to restore service to whatever application it happens to be, you never know a priori what the problem is. By definition, you get a ticket, and that ticket almost always says something, the website is down, their application is slow, those are the kinds of tickets that you see. And unless you have kind of tribal knowledge, you were actually integral in kind of building up all of the components of the system, it's very, very unlikely that you're going to be able to immediately say, oh, the application is down, I know what it is again. Particularly, again, as we are in a world now where these things are generally coupled together via dozens of microservices. And then finally, an inability to cope with the scale and complexity of modern architectures. We're working with a large financial services company, and we were kind of breaking down the components of their check cashing system through their mobile phones. It touched no less than 56 microservices to go through that system. And God knows how many actual servers and virtualized containers were on the back end of that. So when you start thinking about that level of complexity, the number and disparate sources that you have to collect, it really starts to present a new frame, a new way of thinking, a new kind of framework for trying to troubleshoot and get out of constant triage mode, reactive mode with these systems. So as we started to do product development, we really we're working on a framework in our head to make sure that we kept ourselves intellectually honest. And this is the kind of real framework that we're identifying here and kind of walking through today. So the first thing in real is reliable. And we'll walk through at great depth what each of these components means, but I'm just going to walk through them individually for now. A system must be extensible. That means not only can it accept a whole bunch of different data types, but you have the ability to leverage that data for different purposes than you as an operator might have ever envisioned. Analytics. Search as an analytics platform, quite frankly, is just a crazy situation. The idea that you can build a true analytic, deep analytic capability on top of a search subsystem is kind of naive and, quite frankly, a little bit cute at this point. And then finally, limitless. As I said, we've personally built systems up to a petabyte a day. I don't really want to even think about data sets that will fit on a single hard drive, because those problems are quite simple and solvable by existing legacy technology. But that's not the world that we live in anymore. There is no company at any scale that doesn't have at least a terabyte of data, of operational machine data that they generate every single day. They may not collect it right now, but they don't collect it not because they don't want to or they don't think it's valuable. It's either too expensive, too complex, or they kind of exist in silos and they just don't have the ability, or haven't had the ability until now, to collect all that in kind of one single bit bucket. And you can read more about this in the blog post mentioned here. So let's dive a little bit more into the reliability side of the world. So we really want to make sure that we get the data to the point that it's destined for as quickly as possible. What you typically see in these types of, particularly around search, is that indexing is always the bottleneck in these systems. And you've got to get the data from point A to point B as quickly as possible. 15-minute delays in terms of going from an event-generating source to a place where you can actually derive insight out of it is simply not sustainable. And I see that over and over again with our customers kind of struggling with their existing legacy technologies, where I think 15 minutes is a bit of an outlier, but I don't think 3 to 5 minutes is at all of an outlier. And very frequently you'll have a problem wherein you have you'll have a fault, and that fault will create a cascading failure. And within that 3 to 5 minutes, you've already lost control of the system. You're no longer in a place where you could stop the problem from actually causing user downtime, causing system outages, et cetera. You are in a world where you are completely reactive. And we really want to empower operators to the point where they're no longer thinking in terms of reactive, but they're actually getting ahead of these systems. We have a really, really long blog series on kind of error handling and fault tolerance. One thing to also mention here is our system is designed, obviously this is subject to kind of network fluctuations and other variables, but as a design principle, we want our data from the point of generation to the point where we landed in a couple of different analytic systems. It's about 300 milliseconds. That obviously will fluctuate up or down, but that's the design goal. So we really, really focus on going from point A to point B as quickly as possible. Second, we actually guarantee data delivery given a properly configured system. There are systems out there in this space, particularly Elasticsearch, that are known to lose data given a long enough timeline. Happy to talk about in the question and answer session at the end what that situation is. But when we talk to our customers and we talk to our prospects, particularly when you start talking about APM and you're doing transaction type monitoring, losing data is not an option. Think about it in the terms of a compliance situation. So if you're collecting CDR records, for example, in telecom, you can't lose those records. You're going to get massively fined. And so we guarantee delivery of that data. And we also want to be able to resolve queries extremely, extremely quickly. So because we have the luxury of not just existing on a search subsystem, we have the ability to query hot data at petabyte scale in seconds. And I know that probably sounds crazy, but a properly configured and scaled system can certainly do that. Facebook does it every day. We have customers that do it every single day. And we want to make sure that we kind of expose that to the masses. We want to make sure that the tools that Google and Facebook and Yahoo have built over the last 10 years are applied to this problem, and everyone has the ability to query the data with that sort of speed. And then finally, this is sort of tied up into the kind of search not being the greatest analytic platform as well, but you don't want to get bogged down between your storage and your query. You want to be able to maintain the data for as long as you need it. Like I mentioned, CDR records are typically required to be kept for 7 years. At the scale that most telecoms operate, that's dozens of petabytes of data, if not hundreds of petabytes. And the typical way that people handle this now is they either archive it off the tape in the worst case, or they start to they do tiered storage. So you'll do cold, warm, hot storage. That, again, you never know when that data is going to be valuable. At 3 o'clock in the morning, and I don't think CDRs is necessarily the great example here, but imagine if you're a company that's going through a possible breach scenario. And you've actually gone through the effort of collecting all of your data, which is a very rare thing, at least in today's world. But the data that you have is archived off after 7 days. And very, very frequently, these breaches come through systems that we would not normally think of as vectors for attack. We've seen systems be breached through HVAC systems, through the POS terminals. And those are typically never kept online in legacy systems. Because we don't differentiate, there is no hot or cold in a real big data system. Everything is required to be hot because you never, ever, ever can know what the value of that data is going to be when you actually need it. So let's talk about extensibility for a little bit. You really need to be careful about focusing on only known data. And what that means is not only capturing data from sources that are probably, as I just mentioned, very, very esoteric, HVAC systems, et cetera, which don't have modular adapters that just work out of the box. But you also need to be able to do filtering, aggregation, transformation for that data as it comes through the system in order to be able to perform analytics at scale. And quite frankly, to be able to pass it to downstream systems, but we'll get that in 1 second. There is no need in a real big data system to reconfigure the system offline in order to deal with new data elements. You should be able to do that via configuration, ideally built right into the UI. You shouldn't ever have to go back out to the agent, which is something I see very, very commonly in legacy systems. You should never have to touch those agents in any way to do data manipulation, because touching those agents in most scenarios in a production world requires a ticket, requires going through several layers of compliance. And if you need that data right now, that obviously bogs you down and continues to slow the triage process. So what can you collect using a real big data system out of the box? So syslog, application logs, web server logs, database logs, also metrics. And so one of the things that I do think is very important in these types of systems is the co-location of metrics with logs. This is possible with current tech. There are systems out there that do co-locate this now, but because of their limitations on size and scope, it's very, very frequently not done. So typically what you have is something like a Nagios monitoring metrics, and then you have other systems that are monitoring your logs. And I've actually seen people go so far, because these are disparate systems, and in the heat of the moment when you're in a war room, they actually have 2 monitors side by side, and to do correlation between metrics and log, interesting pieces of log data, they actually have a ruler out and correlate visually using a ruler between 2 monitors. It's very, very useful and powerful to have all of these things kind of co-located with one another. We don't want to be a roach motel. These systems simply can't assume that they are going to be the single repository of data and that they are going to provide the analytic framework for every known query that an organization might want to perform. They have to provide open file formats, and we do that both in terms of our what under the covers is Solr, as well as our Parquet file formats on top of HDFS, and these need to be published. So not only can you immediately access this data on top of via our application, you need to be able to access it via other applications. So because these are open file formats, you can lay on top higher order business intelligence tools and need to be able to do so, to do things that aren't necessarily in the core competency of an ITOA tool or a SIM type tool. And so you can think of things like capacity planning. You can think of things like forecasting, business forecasting if you're collecting application performance data. And those tools are always going to be built for that ad hoc analysis, and they're also much more suited towards business analysts who would love to get access to this data, but typically are almost always told, no, you can't have it because you're affecting the scalability of the system, or it's too sensitive. There's a laundry list of excuses for preventing access to this data. And then finally, and I think maybe most importantly, extensibility means the ability to both filter from upstream sources and downstream sources in a limitless way. So effectively what this means is you need a pub-sub architecture. You need the ability to capture all of the kind of upstream data, do transformations, filtering, aggregations, and then if this particular system, this ITOA system that we're talking about here, doesn't deliver the analytics that you're looking for, because it's more general purpose, you have the ability to funnel that data to downstream systems that are purpose-built. And a really good example of this, one of our customers that I'll talk about in more depth in a little bit, actually uses a tool called ExtraHop to do deep packet inspection. And so they capture actually all packets via our tool. They store everything in our tool. And then if we don't have the ability through whatever analytics, but they do feel that the problem lies somewhere in the network infrastructure, they have the ability to go to ExtraHop to use its kind of deep purpose-built analytics, in this case, deep packet inspection, and be able to actually be very successful. And that has lots of ramifications that we'll talk about in a minute. But most importantly, it allows for very, very kind of shallow analytics at the immediate triage needs, and then moving downstream to deep purpose-built analytics for deep triage. It also allows you to create streams of data that you can feed downstream to dashboards, to executives, to whatever, that doesn't cause any slowdown on your search subsystem. So the typical way of feeding these downstream systems has always been, we need to query, we have to write a search query that has impact on the search subsystem, which is part of the reason that these systems aren't widely opened up to the broader organization. And so you can see here kind of how the data flows. I'm going to step through our architecture in 1 second and kind of apply that to this specific need. So let's talk a little bit about analytics, because at the end of the day, that's really what people are looking for out of these systems. One thing that I think is completely broken in the current raft of legacy tools is the out-of-the-box experience that people could really derive a lot of value from. Typically, when you log into these systems, they're completely cold. They're bare. You get a search box, so you can search. But really, what people actually end up doing is building tens, dozens, hundreds of dashboards, and that's actually how they run their organizations and operations. We believe very, very strongly that it actually is it's not that hard to build powerful visualizations out of the box based on a couple of interesting dimensions: location, host, service, and breaking them down by those dimensions allows you to look at particular metrics like event volume, network latency, and you should just do that out of the box. And that's something that is a very, very powerful tool. Additionally, providing anomaly detection. And anomaly detection here just means looking at weird behavior across your data center. And so I like to talk about that as kind of surfacing the unknown unknowns. That's also just out of the box. It's something that we don't expect users to write themselves. And this is true machine learning. This is not your standard heuristic or standard deviation-based fault or alerting mechanism. This takes some of the dimensions that I just mentioned: host location, service group, which can be things like HTTP servers, et cetera, and as well as many, many others. In particular, periodicity is really important here, and applies an anomaly detection algorithm in real time so that you can figure out, without tickets coming in, where faults are likely to start happening in your infrastructure. And so, as I was mentioning, this is one of our purpose-built analytics dashboards, breaking those things down. And a really nice to have here is, or a nice kind of proxy for interesting things going on in the data center is typically one of two things happens when an interesting thing happens in the data center. I won't say good or bad, I'll say interesting. And that is, you'll either see a whole lot more logs or a whole lot fewer logs across a given entity. And an entity can be anything. It can be a logical, it can be physical. Logical would be something like a global representation of all of your data centers, all the way down to the smallest kind of physical entity, something as small as an individual disk controller in a particular machine. And so breaking that down by event volume, you can see here, and I know it's a little bit small, but I can very, very quickly hone in on where the changes are and where the interesting things are by just clicking on quite frankly, the big red flashing lights. Also, you have the ability here to zoom in on an anomaly. Just at the dashboard level, you don't have to go into the search frame, and notice that that frame actually doesn't present any search. And so the ability to hone in on anomalies, particularly across derived metrics, and derived metrics are things that aren't necessarily surfaced by the logs themselves, but are surfaced by the ability to do that transformation, filtering, aggregation that I mentioned before. Having the ability to do that in real time and surface that at a high-level dashboard before you even get to the search, which quite frankly should be the last thing that you do in these systems, not the first, is a very, very powerful way of approaching the problem, and one that I think lots of people are working towards, but are going to be limited by the fact that they are not on true analytic platforms. Additionally, you need the ability to do custom analytics. So that is the ability to process real-time streams, not just query data. And there are a number of different ways you can do that in Hadoop-based systems. Really what people are looking for is the ability to do ad hoc dashboarding visually, but also apply, have API calls, have the streams of data opened up to them as data scientists, as analysts, as whoever, and play with new techniques and new algorithms that we or other competitors may never think of. You also need low overhead for that stream access. Historically, that has been done, again, through saved searches if you want to do streams. And so having a true analytic platform, one not limited to search, one that has SQL availability, one that has raw access to files is a very, very critical need for that. And then finally, you have to be able to create custom metrics. That is quite frankly table stakes in systems like this. A side note on analytics, as I mentioned, came out of Cloudera as well as both of my co-founders, and we spent a lot of time with the largest organizations in the world, helping them in their big data journey. And this is no different than any other. So the crawl phase in this is simply capture. Data capture is, it sounds like it's an easy problem. It sounds like it would be the easiest problem when you want to get to kind of the end state here, which I'll get to in a second. But it's honestly the hardest part of this journey. If you ever heard Josh Wills, who's the head of data science for Cloudera, he says he spends 90% of his time doing janitorial work, cleaning up data, acquiring it, and putting it in a format in which it's usable. And so that crawl part is really where most people are now, is trying to figure out how they can capture all of this disparate data. The walk part is, I think what we think at Rocana as looking at the past. And that's what I think most tools in the space do now. They have a very good view into 5-10 minutes ago, and they'll give you a view typically up to about 90 days ago. And that's typically where you start retiring this data out in legacy systems, because if you keep it any longer than that, it starts to bog down the system. And then the running for us is the present. That's real-time alerts, real-time anomaly detection. That is where I think most people want to be. Most people are kind of really striving to get just to real-time. And then the flying is the predictive. That's the hardest. It's what people want to jump to. And quite frankly, if you try to jump ahead in any part of this journey, you're pretty much guaranteed to fail, because if you don't have a strong ingestion platform, if you don't have that crawl facility kind of nailed down, you're never going to be able to get there. You're never going to be able to kind of move down the chain. Finally, I think the most obvious of the pillars here, limitless. We want to be able to ingest hundreds of terabytes out of the box with no special configuration, with no real special thought given to it, and put all of your data in one single place, the single pane of glass, which is almost always called the holy grail by prospects and customers when I talk to them. That's just something that all of these systems should do without even questioning it. Managing petabytes of stored data. If you want the ability to keep this data online, and you want to store petabytes of CDRs, you should be able to do so. You shouldn't be forced to move it to tape, either because it's expensive in terms of storage, it bogs down the query side. There is no reason that you shouldn't be able to keep this data in an online system, immediately queryable and hot. You also need to be able to avoid data corruption. Very, very commonly we see, particularly I keep harping on the CDR use case, in SANs, in large-scale storage subsystems. This is typically treated, because of the cost and volume, as third-tier data. It doesn't get treated very well, and you'll get very, very commonly you'll have corruption, data loss. And in the CDR world, in the compliance world, that is you can't tolerate it. So you have to avoid data corruption or loss, and we use HDFS, which obviously is immensely reliable, has availability guarantees built into it. I've never had an HDFS system lose data on me personally. And then additionally, we don't want any exotic hardware in the system. Exotic hardware costs in a variety of different ways. It costs in the esoteric setup, the people that you have to hire in order to architect those systems. And obviously, it's extremely expensive just to buy. These systems should run on commodity hardware. There is no reason, given kind of the big data world that we live in now and the proliferation of open source tools that are all designed from the ground up to run on open systems, to buy expensive proprietary devices. And I'll single even specifically out solid state drives here as a really common scenario that I see at the high end of the legacy tool installs. So one prospect of ours has been ingesting roughly 3 terabytes of data a day. And to do so, they were forced to buy, because they couldn't get commodity hardware to perform, they were forced to buy 20 incredibly over-provisioned servers, all with large amounts of spinning disk in them, to the tune of nearly 8 figures. That's just crazy, and that's just on the ingest side. So we want to make sure that we get out of that world, we get people back to a world of commodity hardware. That also generally means a much faster time to resolution if this system goes down, because you don't have to put an order in, or you don't have to keep a hot standby of that esoteric hardware. Why is limitless important? I think a lot of that should be kind of self-evident given the rest of the conversation that we've had, but we're starting to see downtime converted to dollars. And I think this is going to be a trend that is increasing. Virgin Blue had downtime back in 2010, affected 50,000 passengers, 400 flights, cost them $20 million. We see data centers go down every day. 80% of that downtime exceeds $50,000 an hour. 25% of it exceeds $500,000 an hour. And we just saw this a few weeks ago in the form of the United Airlines outage. I haven't seen a post-mortem on that in terms of dollars yet, but I assume that will be coming out soon. No longer is it tolerated from the C-level and from the CMO level for IT systems, particularly revenue-bearing IT systems, to go down. And so if you assume that to be the case, co-locating all of these systems into that kind of holy grail, that single pane of glass, is a prerequisite. So just to dip a little bit into the architecture here, and I'm not going to go too deep into the specifics unless anybody wants to on the in the Q&A session. But you can see kind of we have our data sources on the left. In the kind of open source big data world, historically, there's only been a couple of options for collecting data at the periphery of your architectures. And that's been Logstash, which is written in Ruby, or a tool called Flume, which is actually written by our CTO, Eric Sammer. And they're actually fine tools, but they have one kind of fatal flaw, which is that Logstash is written in Ruby, as I mentioned, requires a Ruby interpreter, which no one wants to run on production servers. Flume is written in Java. No one wants to run JVMs on their production servers. And so you do require some sort of native agent to capture and at the periphery. And so Rocana has an agent written in Go. I'm not saying that's the only way to do it. There are lots of different ways. But you do have to have that agent with a very, very small footprint, constrained, that does a couple of different things. One, does the things that you would expect, tails files, you can spool to directories, but also, as I mentioned earlier, captures metrics out of the proc file system on Linux and does the same on the Windows equivalent. Moving through the system, you want to be able to, again, as I mentioned earlier, capture from a whole bunch of different sources, and in particular, be able to capture on the fly without a lot of forethought. And so providing APIs, either REST, native Java API, what have you, is also a prerequisite. Capturing syslog log files, that's kind of expected out of these types of systems. The event data bus here is represented by Kafka. That obviously could be really any pub sub tool that could work at scale. Kafka tends to be particularly in favor right now because of its scalability and battle hardness, battle testedness at LinkedIn. And then you need to have this event storage, which basically comprises our event data warehouse. And I think that the important bit here is to realize that going back to search not being a great analytic platform, when you land data into a real big data system, it's landed into a couple of different repositories. One that provides faceted search, but it's also landed into a true file system so that you can give access to business analysts. You have the ability, more importantly, to access it using any execution engine that exists in the Hadoop ecosystem. And so now you have tools like Impala, Hive on Tez. We're seeing the emergence of Spark. Tachyon is an in-memory tool. There's so many different execution engines that you might use for different types of analysis. Having just search is silly. It makes literally no sense. So I want to walk through a few customer stories and then dive into a little bit of a Q&A. So the first is a financial services company that's a customer for us. And really their focus was centralized logging. There are a whole bunch of business challenges that kind of surfaced that problem up. But at the end of the day, their problem was that they were such a large organization built up over time, many, many decades by acquisitions, that they had things everywhere. They were just spread out across a variety of different data centers, a variety of different countries. And so centralized logging for them is actually a very, very difficult problem to solve. It also prevented them to get from doing the things that you see here, getting to root cause. Typically, they would restore service by just simply rebooting and hope things didn't happen again, which I see very, very often. It was very difficult for them to onboard new systems, which slows down IT, and I think that points to kind of the shadow IT movement that we see today. They couldn't bring on new applications, and their CMO is constantly yelling at them, asking them why it takes 6 months to provision. Why don't I move to the cloud? And then on the analytics side, they couldn't deliver the tools to their analysts that they need, or the data that they needed to their analysts. Very, very commonly, I've seen this dozens of times. You'll fire off a query in these kind of search-based systems, and because they're not true analytic platforms, that query is a fire and forget. It's fired off on Friday. Hopefully it returns on Monday morning or by Monday morning. Sometimes it does, sometimes it doesn't. And the confidence in that it will is also a really, really unfortunate thing. So we were able to capture 3 terabytes of data a day. We were able to help them capture from esoteric systems. We actually, one of the more interesting things that we did there was actually start capturing data out of a Raspberry Pi-based system that they were using to monitor environmentals in the data center. So they could actually start kind of doing correlation where they would see servers die faster in hotter parts of the data center, which I thought was a particularly interesting use of the system. And then they also had the ability to finally, which they've never had before, trace transactions all the way from website to their mainframe applications. And because they're a financial services company, they tend to run large parts of their infrastructure still on mainframe, particularly on the transaction processing side. So for them, this was a breakthrough in capability. So they were able to kind of grow the top line. One of the other use cases that they had was focusing on churn, which tends to be a very expensive proposition on the marketing side, and collects data, as I mentioned, from geographically distributed sites. They got to that holy grail, the single source of truth for IT operations. It's not really a destination, it's a process. And so as you add new sources, you're kind of never done. Ideally, you're always adding new applications and new customers. So this is, their voyage is never done, but they do have that single source of truth now for IT operations. I want to hand it back over to Michelle here to talk a little bit about, or to start the Q&A session, but I also want to thank everybody for their time and look forward to speaking to you.
Wonderful. Thank you, Don. And if you have questions for Don, go ahead and ask those via the chat feature. I also quickly want to introduce my colleague, Tom Yates. So, Tom, I do see some questions coming in, so if you want to field those, that would be fantastic.
Yeah, sure. Thanks, Michelle. So the first question we've got is there's a guy, he says he works at a, assuming it's a guy, my mistake, works at a mid-sized bank. They have, he says, or she says, about 300 gigabytes of log data a day. And they were curious if, you know, some of the data volumes that you were saying were huge, and they're saying, do you think those data volume growths are limited to IoT-oriented businesses, or is that something he should expect to see at his bank?
Like, as I mentioned, I think that everyone obviously there's a bottom tier here, but I certainly think a mid-sized bank would qualify, has this amount of operational data. It's either rattling around the mainframe in a bank, as I mentioned, they typically operate there, and typically not collected for very long. The website, you're probably only instrumenting certain applications because historically these systems have been priced per byte, which really inhibits people from capturing all of their data. They tend to cherry pick what they think the most valuable data sets to be. So I don't think at all that this is limited even to the Fortune 1000 enterprise, as I mentioned. I think that almost every single business past a certain scale has at least a terabyte of data rattling around. Whether they collect it today or not is a very different question. And I think most, if you were to be intellectually honest and ask CIOs, how much data do you capture out of all the machine data, all the operational data that you generate? It's less than 10%. So if you're typical, and I don't know that you are, but assuming you're typical, that means that you probably do have roughly 2 to 3 terabytes of data rattling around there that you could additionally derive value out of.
All right. Question number 2 is, this person says, I see keeping data for long-term for security purposes, and so I'm an app admin, and I don't actually access data that's much older than a few hours in my job. What are the use cases you see for keeping app data around for a long term?
Application data, well, so you mentioned security, right? And application data is key to, you want to have that single pane of glass against along all of the vectors that I mentioned, storage, network, app, metrics, and logs. So one, if you do have a security breach, you have to have every bit of data because it's not going to be within your 4 walls. They're trying to hide their tracks. So from a security perspective, yes, you need to keep it. From an application perspective, I think it's very interesting from a capacity planning standpoint to keep all of your application logs. from a forecasting standpoint. And then historically, if you're instrumenting deeply, you could actually start to get very, very granular in the analytics, particularly around, and I don't know the use case specifically you're talking about, but around figuring out how to prevent user churn, how to optimize the application for engagement. It really depends on the industry that you're talking about, what you would want to, why you would want to keep it around for a longer period of time. But I'd almost want to reverse the question. Why wouldn't you want to keep it if you had the ability to do so and it was costing you a fraction of what it does now? In these systems, I keep kind of harping on it, but you never know the value of this data until it's 3 o'clock in the morning and you don't have it.
All right, I've got one more question here, and the question is about anomaly detection, and the question is, I already have alert overload, so if I'm looking at a tool that does anomaly detection, I'm a little worried that it just adds to my alert load. Any recommendations how to evaluate an anomaly detection feature to see if it helps reduce my alert load or adds to it?
Sure, and that's a really good question, actually. So we spent a lot of time implementing these types of systems at Cloudera, kind of bespoke. And one of the things that we learned was you have to be very, very purposeful in the algorithms that you apply to these specific problems, because as you mentioned, alert fatigue is the death knell. False positives are the death knell for monitoring systems because they simply fade into the background, and that's exactly what happened at Target, right? They didn't get breached because of a lack of alerts. They got penetrated because they had so many alerts already. When they got breached, everything else was noise. And so we've selected a very specific algorithm for the anomaly detection that we do now that's suited for this type of problem. We've in our past history spent a lot of time thinking about this problem, making sure that we roll it out appropriately. It's a hard problem, and it's something that, particularly on the predictive side, we are going to be incredibly careful, incredibly diligent in how we roll those tools out. And if you haven't built anomaly detection at scale, if you haven't stubbed your toe in every way imaginable, which we have, unfortunately, or fortunately, depending on your perspective, it's something that you kind of have to learn through experience. Additionally, one of the requirements for these sorts of anomaly detection systems, and it's something on our roadmap, it's not there today, but in order to minimize that kind of false positive, you start as an unsupervised system, right? So when you first start collecting data, you have what's known in big data circles as the cold start problem. You have to start collecting data, establish a baseline. And so from that baseline, the algorithm starts, it's in an unsupervised mode. It starts based on the model that we've created to figure out what's anomalous across the dimensions that I've mentioned. After that, after you've hit that baseline, what we've added to the roadmap is the ability to actually do supervised. So to kind of switch to a supervised mode. So you can give an anomaly a thumbs up or thumbs down. I also think that's a prerequisite to being successful in any kind of anomaly detection algorithm, particularly in these sorts of devices. And so that's how Google thinks about the problem. When they do recommendation systems, and their ad serving system is probably the largest scale recommendation system in the world, their thumbs up, they don't have a thumbs down, but their thumbs up is when you click on an ad. And so the more that you use the system, the more that you actually inform the system as to what is right and what is wrong, the more accurate it will become over time. And then on the back end of that, it is possible. People can make mistakes. You need to have the ability to kind of clear that system out over time. And so that's also something that's important in the anomaly detection side.
Excellent. Thank you, Don. Thank you, Tom. I want to thank you, everybody, for joining us today. That is all the time that we have. If you do have additional questions about real big data, please email us at sales@rocana.com. Again, thanks, everyone, for joining us. Tom, thanks for your great questions, and Don, thanks for the great presentation. Have a great day.